All right, you guys, so we should have out the homework from yesterday where we had to determine if lines were parallel, perpendicular, or neither. So just a little review. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. And neither lines will not have the same or opposite reciprocal slopes. So at the end of the hour yesterday, I went through how to find our slopes. Remember, when they are parallel lines like we have here and here, they should have the same slope. So you can see 2/3 was the slope we ended up with for both of those. So since they have the same number, we can say lines J and K are parallel, okay? Now when we have opposite reciprocal slopes, as you can see here, we had -5/9 and we had +9/5 for K. So when we have the same slope, that they're going to be parallel. When they're opposites, meaning one's negative, one's positive, and they're flipped, right? 5/9 flipped is 9/5, we end up saying that they're perpendicular. So you can see we wrote here opposite reciprocals, so line J is parallel to line K. Or not parallel, line J is perpendicular to line K. And then we have our neither. So if you look at the picture, we've got line J and line K. Line J ended up with a slope of -9, whereas K's slope was +6/5. So since we have neither the same exact number and we don't have opposite reciprocals, we say that these lines are neither parallel nor perpendicular. So let's check your answers on the back. So number 1, we should have ended up with the slope of J being -1/2, the slope of K being 2. Now, if you didn't get that, look at your actual slope, right? For J, we had to do 0 - 2 over 2 minus -2. So that ended up being -2/4. And if you reduce that fraction, it becomes -1/2. For K, we should have had -2 minus 4 over 1 minus 4. So -6 over -3, which is +2. And since we have -1/2 and +2, they technically are opposite signs, right? Negative, positive. And then 1/2 flipped would be +2 over 1, which is the reciprocal. So we have perpendicular lines. Looking at number 2, we should have J to have a slope of 5 over -5, which is -1. K has a slope of -3 over -3, which is +1. And -1 over 1, those are opposite reciprocals, right? 1 over 1 flipped is still 1 over 1. So you have a -1 and a +1, so we should have perpendicular lines. Number 3 here, we've got J's slope to be -3/4. K's slope is -1, right? Remember, 3 divided by -3 is -1. And if you look at these, we end up with neither. They're not the same, they're not opposite reciprocals, so we should have said that these lines would be neither. Looking at number 4, we should have that J has a slope of 8 over 1 or +8. K had a slope of -2/5, which these are neither. Okay, they're not the same, they're not opposite reciprocals. Right, number 5, we have line J ends up with a slope of 5 over 5, which is +1. K also has a slope of +1, right? 3 divided by 3 is +1. So since they both have a slope of 1, the lines are parallel. And then we have our last one, number 6. J, we should have ended up getting a slope of -8 over -10, which reduces down to +4/5, right? I can divide both 8 and 10 by 2. And then K's slope is -10 over -8, which reduces down to +5/4. Now these at first appear to be perpendicular, but if you look closely, they're not opposite reciprocals, they're just reciprocals. So since one is not a different sign than the other, you have to say neither. All right, so go ahead and pass up that homework to the front, and then I'll have the substitute collect it for me. And then you can go ahead and have out your notes. So go ahead and press pause for me for just a moment, and then when you're ready to hear the notes, press play. So when you came in today, you should have picked up the following notes. Okay, so go ahead and have that out. So today is a bit of a review. We are going to be writing lines or equations for lines of parallel and perpendicular lines. using the form point slope or slope intercept form, okay? So before we do that, let's go ahead and review again what we need to know about parallel and perpendicular lines and their slopes. So for two lines to be parallel, they must have the, and hopefully you know what to fill in here. Hopefully you're filling in the same slope. Okay, so go ahead and do that for me. For two lines to be perpendicular, they must have the, or must have three words: opposite reciprocal slopes. So take a moment and I want you to write the slopes of all the lines that would be parallel to a line with a given slope. So for example, if I had a slope that was 2/3, the line parallel to that line that has a slope of 2/3 would also have to be 2/3. If I had a line that had a slope of 2/3 and I wanted it to be perpendicular, that slope would have to be -3/2. So go ahead and do that for me very quickly. Okay, so our slope of our line that is -4, the parallel slope would have to also be -4. If my original slope for my line was -1, the line parallel would have to have a slope of -1. If my original slope was -3/7, the other line would have to have a slope of -3/7. And then if I had a slope that was 1/5, the line parallel would also have to be 1/5. So basically when it's parallel, the lines are exactly the same slope, so they're going to be the same number. So when it's perpendicular, they always have to be opposite reciprocals. So if you think about the number -4, it's -4/1. So if I want to write the opposite reciprocal of it, I'd have to flip -4/1. So it become 1/4, right? I flipped it and I've made it the opposite sign. Again, thinking of -1/1. When I flip it, it's going to be 1/1. And it has to be positive, so we end up with +1 as our slope. Now when you flip -3/7, it's going to be 7/3, but we need to be an opposite sign, so we should have a slope of +7/3. And then 1/5 flipped is -5, right? Got it. Again, they have to be opposite signs. So a quick review from Algebra 1, we have two different forms. We have slope-intercept form, which is y equals mx plus b, where m always represents the slope of the line, b represents the y-intercept. So if you think again of a graph, the slope is how steep this line is, whereas the y-intercept is where this line is crossing the y-axis, that point right there, okay? Now, point slope is used when you are given a point that's on the line that's not the y-intercept. So it could be a point anywhere, okay? And then you're also given the slope. We actually use this a lot with this specific type of problem. All right, so in this example, it says write an equation of a parallel line. It wants us to write the equation of a line that's going to pass through this point, -1, 1, that's going to be parallel to the line y equals 2x minus 3. Okay, so before we do that, we have to identify a point and a slope that we're going to plug into this point slope form. So it already told us the point it wants us to pass through, right? We want it to pass through the point -1, 1. And we want it to be parallel to this line, right? Y equals 2x minus 3. So what is the slope of that line? Remember, y equals mx plus b. So your slope is 2. So in place of m, we're going to plug in 2. So we can write out our general form here. Y minus y1, I'm going to leave a little blank for it, equals m, which is our slope, and then we've got a parenthesis, and then it's x minus x1. So we've got x1 here, we've got y1 here, and then we're going to plug in, of course, our slope. So as you can see, it's y minus y1, which our y1 is 1. So y minus your y, which happens to be 1, equals, I'm going to plug in the slope here, which is 2. And then parenthesis x minus your x1, which happens to be -1. So once you plug that in, we just have to get it into y equals mx plus b form. So let's do a little bit of simplifying before we do that. Notice that x minus a -1 is really x plus 1. And then we just distribute the 2. So 2x plus 2. And then we can move the 1 to the other side. And now we have the equation y equals 2x plus 3. So this equation would be parallel to this line. All right, let's check out another one. So this time we are writing an equation that's going to pass to the point -8, 2 that's parallel to this one. Now as I'm looking at this, I have no clue what the slope is. I need to get this in y equals mx plus b, so that way I can actually tell what the slope is going to be. So to do that, I'm going to move the 3x to the other side of this equation using algebra. So this cancels, leaving me with -4y on the left, and then on the right side I've got -3x plus 12. And then I can get y alone by dividing everything by -4. So I end up with y equals 3/4 x minus 3. So now I can identify the slope and the point that I want to plug into the point slope form. So my m is always the number in front of x. So I'm going to plug in 3/4 in for m. And then my point was -8, 2. Okay, so I have to plug that into point slope form. So again, it's always y minus our y, which happens to be 2, equals our m, which is our slope, and then parenthesis x minus our x, which is -8. And then we simplify. So minus a negative is going to become a plus. We'll distribute that 3/4. So we end up with 3/4 x plus 3/4 times 8. So quick review over multiplying with fractions. Remember, you put them over 1, and then you just multiply across. So we end up with 3/4 x plus 3 times 8 is 24 over, and then we multiply across here, 4. So it's really 6. And then I'll just bring down the y minus 2. And then we can get our y alone by adding 2 to both sides. So our equation is y equals 3/4 x plus 8. So this line, y equals 3/4 x plus 8, would be parallel to the original line, y equals 3/4 x minus 3. All right, so now we're going to try one where the line is perpendicular to this line that passes through this point. Okay, so again, we need to figure out what the slope is for the original line before we can identify its perpendicular slope. So to do that, just like before, we're going to get y alone in y equals mx plus b form. So we can subtract 2 x's from both sides. So we end up with y equals -2x plus 2. So the original slope is, again, the number in front of x, which is -2. We need our line to be perpendicular to this line. So our perpendicular slope has to be the opposite reciprocal of -2. So the opposite of negative would be positive, and then the reciprocal of positive 2 would be, or positive, the reciprocal of 2 would be 1/2. There we go. So we end up with our opposite reciprocal to be positive 1/2. And then our point, like we already said, was 2, 3. And then we just plug these in to our point slope form. So y minus our y, which is 3, equals our slope, which is 1/2 parenthesis x minus our x, which is 2. And then we just have to simplify it into y equals mx plus b form. So distribute the 1/3, or the 1/2. So we have 1/2 x minus 1/2 times 2. I'll put that 2 over 1. Bring down the y minus 3 over here. And again, we multiply across, so this is still minus. So 1 times 2 is 2. 2 times 1 is 2. So it's really just the number 1, right? So all we have to do is add 3 and we're done. So our equation would be y equals 1/2 x plus 2. Okay, that would be the equation of the line that's perpendicular to the original line, 2x plus y equals 2. All right, on to the back. We're writing an equation for a line, again, that is perpendicular to this line. As you can see right now, we're not really sure what the slope is, so let's figure out what the slope is. We gotta do a little bit of algebra first. So distributing that -2 into the parentheses, we've got -2x, and -2 times +3 would be -6. And then we just add 4, right? So the original equation for this line would be y equals -2x minus 2. So our original slope is -2. Since we want our line to be perpendicular to this one, I have to use the perpendicular slope of -2, which negative would be positive, and then 2 over 1, the reciprocal would be 1/2. Okay, and we want it to pass to the point 2, 3. So I take this and I plug it into our point slope form. So y minus my y, which is 3, equals my slope, 1/2, parenthesis, x minus my x, which is 2. And then we'll just distribute that 1/2. So 1/2 x minus 1/2 times 2. I'll change that 2 into a fraction by putting it over 1. One times 2 is 2. 2 times 1 is 2, so it's really 1. And then we just need to add the 3. So our final equation here is y equals 1/2 x plus 2. So that would be the equation of the line that's perpendicular to this one that passes through this point. So I'm going to have you do the U-tries in just a moment, but before we do that, I want to go over this very last example. It says, how do you know that the lines x equals 4 and y equals 2 are perpendicular? So let's review again how we graph those lines. So remember, the line x equals 4 has to pass through the x-axis at 4. Every point on this line has to have an x value of 4. So again, if you think about it, this would be the point 4, 6, this would be the point 4, 2, this would be the point 4, -4. So this is the equation x equals 4. Now when we go to plot the y equals 2, every point on that has to have a y value of 2. So if you go to the y-axis where 2 is, and you make sure you draw the line through that y-axis at 2, that should be the line y equals 2. Again, thinking about all the points on this line, they'd all have a point where the y value is +2. Now, how do we know they're perpendicular? Well, think about it. I've got a horizontal line, I've got a vertical line, and they should always be perpendicular. So we can just say horizontal and vertical lines are always perpendicular. Okay? All right, so I'm going to have you guys go ahead and do the U-try. And then when you're done, I'm going to have you bring it up to the substitute, have you check your answer with the answer key, and then if it's correct, you can get the worksheet for homework. All right, have a great weekend, you guys, and go green.